let me sort of tell you here what they're used for. Okay, so what I can do with a half angle is I can find a value like a sine or a cosine or a tangent that may not be on my unit circle. Okay, so for instance, like 30 degrees. Okay, what would half of 30 degrees give me? 15. Okay, so what I could do is I could find the sine or the cosine or the tangent of 15 degrees because the 30 degrees is on my unit circle. So same thing with like any other angle. So 45, what would be half of 45? Yeah, 45 over 2. Okay, I like it in the decimal form better. It's kind of easier, but it would be 22.5. Okay, but using the 45-degree angle, I could find the half angle. I could find like the sine or the cosine or the tangent of 22.5. Now, it wouldn't make sense to use it 60. Saying what's half of 60? 30, and it's already there. Okay, same thing with 90. It wouldn't really work because half of 90 is 45. Really wouldn't work for 120 because half of 120 is 60, and you already got that. But 135, okay, what's half of 135? I really don't know what that is. Punch it in for me. Shoot, I don't know. 67.5. Okay, so I could find the sine or the cosine or the tangent of 67.5 using what's called the half angle formulas. Okay, now let's actually look at the first two half angle formulas. Okay, so this is, again, you label them your half angles. They're over there on your left, so you don't have to memorize them. Okay, all right, now we're going to say something about that plus or minus sign here. It's not really plus or minus the way it looks. Okay, so that plus or minus sign doesn't stay there. I'll let you guys get them copied down, and then I'll tell you about them. All right, now here's what you have to do with that plus or minus sign. Okay, again, it's not really plus or minus, but it's more like, it's a question. Okay, so what we're asking there is it plus, okay, or is it minus? Okay, I guess we could say probably better, is it positive or is it negative? Okay, it's one or the other, it's not both. And so let's see if you guys can kind of figure out, how do you think I would figure out if it was plus or minus? It's a critical thinking question. How could I figure out if the sine or the cosine of an angle was positive or negative? The quadrant. Okay, what quadrant is it in? And so that's going to tell me if it's going to be positive or negative. Okay, now, and usually you kind of run into problems. You have to look at two numbers, and you have to decide, which quadrant does this lead me to? And so this is why I say this, okay, and I'm gonna put it in all caps here, is you do the sign first. Okay, figure that out first. Is it positive or is it negative? And then you can start plugging into the formula. Okay, that's really important because that's usually the first of three things that people want to miss with these problems, is not getting the right sign there because they look at the wrong number. And if you find the sign first, then you don't really have that issue. Now, you have two formulas for a tangent. Okay. Now, one thing about the tangent formulas is you don't have to worry about the plus or the minus sign. Okay. But this one, tangent of a over 2 is 1 minus cosine a over sine a. And this one has an alternative formula I usually don't use this one, okay? But let me give you the second one. And it's kind of like, you remember how cosine, the double angle for cosine, there's 3 formulas for it, but it doesn't matter which one that you use. Same thing here. Doesn't really matter which formula that you use, but the other one here, is just 2 of them, okay? This one is sine A over, I don't remember this one, 1 plus cosine A, okay? Now, usually this one is preferred, all right? And here's why. Usually what happens is the denominators are pretty likely to have a radical in them, okay? You're probably going to see a radical in the denominator. So you're going to have to rationalize. So would you rather rationalize what would be a single radical or 1 plus that radical? What would be easier to rationalize? The single radical, right? Because if I have to rationalize this as a radical, what do I have to multiply by to rationalize it? Yeah, 1 minus, you'd have to multiply by the conjugate, right? So you would need a conjugate to rationalize that. I wouldn't need a conjugate to rationalize that one, okay? And so that's why I kind of go with that one more, because it's easier to rationalize with. And there again, let's notice on these, you don't have a plus or minus sign, do you? So you don't have to figure out if it's plus or minus. Now, let's look at some examples here, and let's notice why we call them half angles. Remember double angles yesterday? It was what, sine of 2a or cosine of 2a, and so 2 times a meant double. You see where half comes in? Where's the half come in at? Yeah, you divide by 2. Okay, a over 2. It's a half angle. So that's what's going to help me remember that the names of these formulas are half angles. Now, I'm going to kind of look at your worksheet here, and you'll need your unit circle out too. I'm going to do this. I'm going to do one like number 37, okay? So I'm not going to do number 37, but I'll do one like it, okay? So I think 37 says the sine of 15 degrees. I'm just going to do the cosine of 15 degrees because it's not going to be that much different if it's sine or cosine, okay? Now, first thing, write down the formula, okay? So we'll get cosine of a over 2 is equal to plus or minus the square root of 1 plus cosine A over 2. Let me get this ready for next. All right. So now, first thing, what did I tell you just a minute ago here? Go away, calculator. Figure out the sine, okay? All right, so let's see. Do the sine first. Now, let's look. The cosine of 15 degrees. So where is 15 degrees at? First quadrant. Okay, is cosine positive or negative in the first quadrant? It's positive. So I'm just going to scratch out the negative sign. It's just positive. Okay, really in the first quadrant, everything would be positive, wouldn't it? Okay, all right. But let's say, for instance, we were doing this one. What if it was 75 degrees? Or I'm sorry, I screwed that up. What if it was like 165 degrees? That would be in the second, and it would have been negative. Okay? Now, let's figure this part out. What's the angle A? Okay, so you kind of ask yourself this question, all right? What could I take right there, that A, and divide by 2 and get 15 degrees? I just gave it away. 30. Okay, does that make sense? So the A angle is 30. And so all we have to do now is just plug in 30 degrees for that angle A. Now, The reason why I say find the sine first is when I'm trying to tell what quadrant that I'm in, I'm looking at this angle, not that one, okay? And that's why I tell you to find the sine first, because if you're finding the sine first, you're not even looking at that angle, are you? Okay? You're looking at this one to figure out if it's plus or minus to see what quadrant it's in. Now, let's fill out our formula. Now, since it's positive, I don't have to put the positive sign. And now this is going to look really awkward when we write this, but just go with me here. So we got 1 plus, now, what is the cosine of 30 degrees? Square root of 3 over 2, okay, over 2. And what's really awkward about these, especially with sine and cosine, is you get a square root inside of a square root. The answers always look like that. Now, what we've got to do with this, though, is simplify it. All right, so to simplify these, you remember what you call these, and we did this some like in Algebra 2, they're called complex fractions. See if you guys can figure out what could I do to this to like simplify it. The thing with squaring is you can't really square this side. Okay, it's a good thought because it would get rid of the square root. Right, multiply by what? 2, because it would clear the fraction out of it, wouldn't it? Okay, and we can do this because if we do it to the numerator and the denominator, what we're really doing is just multiplying it by 1. So I'm going to multiply every term by 2. So what's going to happen, especially on that term, what's going to happen to the 2? It's cancel. Okay, now let's bring down the big old whopping square root here. All right, 1 times 2 is 2, and we said these would cancel. Okay, so that'll just leave me with square root of 3. And now this always comes out to 4. Okay, because you're always going to multiply by 2. And then think about it, on your unit circle, besides on your quadrantal angles, what's every single denominator? 2. So it's always 2. Okay, and so this is always going to turn into 4, which works out really well because 4 is a perfect square, isn't it? The square root of 4 is 2. Okay, let me make you some notes here. What we did right here is we multiplied everything by 2, so we can clear the fractions. And now what we're going to use is that the square root of 4 is just equal to 2. Now, when we do that, we're taking the square root of the 4, so the 4 doesn't go under the radical anymore. So the big radical, what's going to happen to it? It's what? It's not going to be on the 2, is it? Because I took the square root of 4 and got 2. It's only going to be in the numerator. Does that make sense? Did y'all see what happened there? Okay, I took the square root of 4 and got 2, but yet the square root sign doesn't do this anymore, does it? Okay, it only does the numerator because I took the square root of the denominator. Now, so I heard somebody say cancel the 2's. Can't do that. Well, that's true. I didn't think about that. One's in a radical and one's not. The other thing is this is adding, right? And when I cancel, it has to be multiplication. Okay, yes. All right, so that's, you're talking about the multiply by 2 thing. Now, what makes that legal is what I'm doing here is I'm multiplying the numerator and the denominator by 2. Okay, and so if I do that, what am I really multiplying by? 1. And if I multiply by 1, it really doesn't change the value, does it? It just simplifies it. So that's why that's legal right there. Okay, because you are right, it's not 2 sides. We're not multiplying both sides by 2. We're doing the numerator and the denominator by 2. So you're really just multiplying by 1. Now, that looks pretty awkward there, doesn't it? Okay, but that's the answer. Now, we're going to check it with your calculator here. Get your calculator out. And be sure you're in degrees. All right, So we're gonna punch in um, cosine of 15 degrees. I hope I'm in degrees. I didn't really check it. That's not in degrees. Hang on. There we go. All right. So cosine of 15 degrees is about 0.96 something. Now, that should be the same thing as this, right? Okay. So let's punch this in, and that's kind of complicated to punch in right there. But if you use your fraction template, it's not that bad. So I'm going to bring in my fraction template. All right, so in the numerator, we got big square root 2 plus, and then little square root 3 over 2. Right, did y'all follow how I punched that in okay? It's not really that bad once you punch it in. All right, so notice that's the same thing, isn't it? Okay, so all these half angle problems like this, I can check. Namira, look up here, put it up. Now, let's do another one here. Okay, let me do one like 41. Okay, so this isn't 41. I think 41 says cosine. I'm just going to do sine because it's basically going to be almost the same thing. All right, now let's write down our half angle formula for sine. 40, what did I say? Like 41. It's like 41. Right. So I think the one on your sheet is cosine. Right. I'm just going to do sine. So if I do sine, you can figure out cosine. All right. Now, let's look. I got to write down my half angle formula. So sine of a over 2 is equal to plus or minus big honking square root. Is it like 1 minus cosine a over 2? Did I write it down right? Is that right? Okay, thank you. Now, all right. Now, what did I say do first? Find the sine. Do not find that angle first, okay? Because if you find that angle, you're going to say, well, which angle am I supposed to look at to get the sine? All right. And if you don't find it first, if you'll find the sine first, you don't have to worry about that question. Now, so let's think about it. 157.5, what quadrant? Second. Okay. Now, sine is positive in the second. So my sine there is going to be positive. Okay. Now, the one you have is cosine. Okay. So let's pretend just a minute. What if that was cosine? It would be negative, yeah, because in the second quadrant, cosine is negative. Okay. Now let's figure out angle A. Okay. So let's try to find the angle on our unit circle that I can take and divide by 2 and get 157.5. So I think that's 315. Somebody check me. Is that right? Okay. So 315 divided by 2 would give you 157.5. So what we're going to use for angle A is that 315 degrees. Yeah. Mm-hmm. So, you wouldn't get one where you couldn't find the angle to divide by 2 off the unit circle. Okay? Now, let's put in right here. This is going to be 315 degrees. Okay, now let's evaluate. Now, again, since it's positive, I don't really have to bring down a positive sign. Now, what is the cosine of 315 degrees? All right, right. Say minus square root of 2 over 2 over 2. That's lots of 2's there. Now, from here on, they all end up working out the same thing, or the same way. You always, multiply by what here to clear out my fractions? Multiply by 2, okay? And then the 2 in the denominator is going to change to a 4, and the square root of it is going to give you 2. Same thing every time, okay? Now let's do that. We'll multiply everything by 2. And see this fraction right there, it's always going to be over 2 because it's coming off a unit circle. Okay, now we got to multiply this one by 2. So let's see, this is going to give me big old square root of 2 minus, now what's going to happen over here? Cancel, all right, so it's square root of 2. And I'd like to do these cancel. No, because that's just a 2 times a 2 is a 4. Okay, now the square root of 4 in the denominator is just 2. Okay, so what happens to the big square root sign then? Right, just the numerator. So just 2 on the denominator and then square root, big square root of 2 minus and then little square root of 2 inside. Okay, do y'all want to check this one on the calculator now? You want to kind of go over that? Yeah, we can check. See, that's the nice thing about these exact values here. We can check them all on the calculator. So now we were really finding the sine of 157.5. All right, do what now? Because we took the square root of it. Okay, so you see how the square root right here is on the 4 because it's on the whole thing. But then I take the square root of it and it turns into 2, and now the square root sign doesn't cover the denominator. Okay. All right, now, so in decimal form here, that's really like 0.38. Okay, now let's punch this in and see if that's the same thing. So let's see. Square root of 2 minus square root of 2 over, oh, I forgot my fraction thing. Crap. I'm going to try this. I'm going to be slick. I'm going to paste that joker in there. I wonder if it'll do that. Look at that. All right. That was pretty smooth. All right. Now, there it is. Okay. All right. So let's see. Was that the same thing that I got? Yeah, because that 0.7 was just the numerator. Let me make sure. Yeah, that's the same thing. Okay. So you can check all of these here on our calculator. Now, let's do a tangent one. Okay. And I tell you what I'm going to do. I'm going to do number 44. Okay. All right. This one's got the tangent of 112.5. Okay. Now on tangents, you don't have to figure out the sign. There's no plus or minus sign. There's no square root. Okay. But I'm going to use that easier formula over there. So tangent of a over 2 is equal to 1 minus cosine a over sine a. Okay. So don't have to worry about my sign. Now, let's figure out though right here, what's that a angle? What can I divide by 2 and get 112.5? 225. Okay. All right, so that's our angle A, and we're going to plug it in over here and then evaluate. Okay, so I just asked, well, what would I divide by 2? What angle could I divide by 2 off my unit circle and get 112.5? Okay, so you might have to do a little bit of trial and error there. Okay. Yeah, you can do that. Okay, you say 112.5 times 2. I tend to think backwards on these. So I know it's not very smart the way I do it, but yes, you could just take the angle and multiply it by 2 to figure out what angle A is. Okay. All right. Now let's throw it in. All right. What is the cosine of 225? I don't know. Negative square root of 2 over 2. So since it's minus right there, you just say plus square root of 2 over 2. Okay. And now the sine of 225 is also negative square root of 2 over 2. And now, even though you don't have that square root, it's the same step it is like with sine or cosine. What do you think it is to simplify? Yeah, multiply everything by 2. Okay. Times 2. So we get 2 plus, and then guess what happens here? cancel. All right. And then these twos cancel. So it's just negative square root of 2. Okay. But right, we got to rationalize. All right. Another problem that you have is you have a negative sign down there. Okay. Now, so you could distribute it to the top, or let's just do this. When we rationalize, we'd multiply by square root of 2 over square root of 2. How about we multiply by negative square root of 2 over, and that takes care of two things at once. Okay. So let's multiply by negative square root of 2 over negative square root of 2. And there again, notice, go back to the tangent formulas with me just a second. You see why I don't really like that? Because if I'm rationalizing that, I'd have to use a conjugate. Okay, so it's much easier to rationalize here if I don't have to multiply by a conjugate. Now, what I'm afraid you're going to miss, though, is when you multiply that negative square root of 2 over there, is you have to distribute. Okay, so you get 2 times negative square root of 2 would just be negative 2 square root of 2. And then positive square root of 2 times negative square root of 2 would be negative 2. Now, it'd really be minus the square root of 4, but then that would just be 2. All right, over. Now, negative times a negative means positive, and square root of 2 times square root of 2 is just positive 2. All right, now, you notice we can reduce out by 2. Okay, so that would give me negative square root of 2 minus 1, and I wouldn't really have to put over 1. Okay, that's it. All right, do y'all want to check that one with the calculator, or no? Okay, I don't really want to check it either. Now, but you could check it. Let's just make that point. Now, look at like the very last one that you have to do. By the way, we're doing what? You're supposed to start here in just a second. On the half angles, 39 through 45 odd. I'm writing this down for all the people that's out so they can see which ones to do. Look at like number 45. It's a tangent one. All right, but what do you notice there that's a little bit different? Number 45. It's in radians. Okay. Yeah. So that's the easiest solution, is to convert it. Okay. Instead of trying to figure out what radian angle I would divide by 2 to get 7 pi over 8, just convert it to degrees. It's much easier. Do y'all want me to do like number 46 with you real quick? All right. If you want to watch 46, you can. Otherwise, you can go ahead and start on them. Okay. But I'll do 46 with you. Okay. It's another tangent one. So you got tangent of 3 pi over 8. So on my half angle formula, let's see, this is number 46. Tangent of A over 2 is equal to 1 minus cosine A over sine A. All right, so what divided by 2 is 3 pi over 8? I have no idea. Okay, so let's do this. Let's change 3 pi over 8 in terms of degrees. Okay, so here we go. 3 pi over 8 radians. How do we convert here? There's pi radians in 180 degrees. So the pi radians would cancel. Now, y'all help me out right there. What's 3/8 times 180? 67.5. Okay. Now, is that what angle A is going to be, though? Okay. I got to figure out what would I divide by 2 to get 67.5. That would be what, 125? 135. Okay, sorry. So angle A is 135 degrees. Let's put it up here. Okay. Now let's just evaluate with my unit circle here. All right, 1 minus. Now, what is the cosine of 135? Negative square root of 2 over 2. So that would just really be plus square root of 2 over 2. And then the sign is square root of 2 over 2. All right, now we're going to multiply everything by 2. Y'all okay if I don't show it? That's going to be what? 2 plus square root of 2 over square root of 2. All right, you got to rationalize it. Oh, and let's remember this. I didn't mention it to my other classes. We need to do this, don't we? So we can get partial credit if we mess up. All right, so let's see. Let's distribute 2 times square root of 2 is 2 square root of 2. And then square root of 2 times square root of 2 is just 2. And again, square root of 2 times square root of 2 is just 2. Now let's just reduce out the 2. So it'll be square root of 2 plus 1. Okay. All right. Y'all start on those. The answers are on the back, so check them as you go. If you miss one, call me over. All right. If you had any trouble with your double angles from last night's homework, okay, call me over and I'll look at those problems if you missed one of those.